Good evening, ladies and gentlemen.
Hi.
It's like day 6 and I'm still teaching you how to say that. Welcome to the, you know that you did the first lecture as well, but welcome to the final evening lecture at Scifest Africa 2015. And again, it is a great privilege for me to be able to introduce Jim Adams, Deputy Chief Technologist of NASA, to you. Jim has spent the entire week with us. Before I tell you a little bit about him, I just want to say thank you to you, Jim, for the incredible amount of work that you have put in at this festival and your willingness to share with all our audiences. We have worked this man to death on outreach for lectures, running Google Hangouts, putting together Google Hangouts, handling, the NASA contingent. He's been a fantastic support. And before I introduce him, I'd like to of course, that means he has to come back, but we'll discuss that later. So, Jim Adams has been with NASA for 25 years. Before being the Deputy Chief Technologist, he was the Deputy Director in the Planetary Science Division. How many missions, Jim?
30.
The last time we counted, just saying. 30 missions for NASA, and of course, well, one of the coolest things I think is that he's worked on 3 of the Mars NASA rovers and was directly responsible for those. Jim was with General Electric before joining NASA. He has a BSc in physics, MSc in engineering, outstanding NASA Outstanding Leadership Award, Outstanding Achiever Award. I mean, the list of awards at NASA goes on. He's quite a big cheese, but he won't tell you. So, Jim, welcome, and thank you very, very much for spending this week with us, and we really do hope we will welcome you back.
Well, thank you, Anya. So one of the things that Anya was pointing out was I was an opening lecturer, and now I'm one of the final lecturers, I guess. And the main reason was she worked me so hard throughout the week trying to make sure that I would finally get it right. But in fact, it has been just an amazing week. So many people had an opportunity to meet so many people, had an opportunity to talk to kids from this high to that high, adults, other researchers, people interested in technology and science outreach. I just really, I feel like I've gotten more from Scifest than the Scifest company. So you should all thank Anya Farid for pulling that together. So the one instruction I have tonight is keep it on time. Apparently there's dinner following this or something. But anyway, I'm prepared to spend the next hour with you talking about how investing in space technology changes life on Earth. And I have about a 30-minute presentation. And after that, I'll answer questions on almost anything. So I guess with that, we'll start. So the space industry on Earth, the global space industry, runs about $330 billion a year. NASA's budget is a tiny fraction of that. What happens is industry picks up the innovations from governments and they commercialize them, and then they make a business out of it, and that creates an economy, or a marketplace and an economy. You heard Elon Stofan lecture mention that for every dollar NASA spends building spaceflight hardware or doing missions, we see a 4-fold return. Well, that's just in that one budget year. There's a trickle-down effect that lasts for decades. And so some of the things I'm going to talk to you about tonight, my favorite spin-offs, my favorite things that industry has picked up from NASA technology, have been in development for decades. So they may see, one or two of them may seem a little old, but that's because they seem to be very high value payoff for the industry. When we started the space program, and this is not the start of the space program, but it's representative of the space program's early days, 1969. Actually, I believe this is 1972. We would land the moon, and in order to do that, we had to solve an enormous number of problems. How to keep astronauts alive in space, That would be the Gemini and Mercury programs. We've had to figure out how to move around on the surface. That's the rover you see in the picture. We had to figure out what to do with the stuff that we collected. That's actually, you don't see that, but there's a curation facility at Johnson Space Center where everything that's been to space and come back is curated and available to the nations of the world to research on. There's been incredible solutions to incredible problems. And along the way, we've invented things that industry can pick up as well. But we didn't stop at Apollo. We entered a spacefaring age, and we built this amazing machine. And to this day, I believe it is the most complicated, most amazing space plane ever built. And we used it to build one of these. Nations of the world come together and do research in space to establish a foothold outside of their nations, beyond the edge of our own planet, just barely reaching out. And it's a place of peace. It's a place where the nations of the world have gotten together to build this and occupy it. And right now, normally there's 6 people on board. Right now there are 3 people on board. And just very soon here, very shortly, Russia will launch 3 more to occupy the International Space Station, one of whom will attempt to spend an entire year in space in the name of medical research to try and understand the effects of space on the human body. In addition, our scientists said, well, we can exploit space too. We're going to fly the Hubble Space Telescope. We're going to build a telescope in space that will be like none other. A telescope that is outside of the atmosphere, and so therefore we don't have the problems from atmospheric interference, and we can also point it steady and hold it for longer periods of time. We can get integration times that are much higher than you can on Earth. That's a challenge in and among itself as well. I don't have a slide on it, so I'll just mention that some of the sensors devised for the Hubble Space Telescope go into mammography machines that are used all over the world now. And one of the crowning achievements, I feel, of planetary science at NASA is the landing of the Curiosity Rover on the surface of Mars. We were able to go from, I believe it's a 12 kilometer per second speed to 0 in 7 minutes. And in order to do that, we had to come up with some amazing technologies, heat shields and pyrotechnics and aerodynamic solutions and rocket supersonic speeds that at first we found out they were firing backwards, and just a variety of other, and ultimately a sky crane. I mean, we used to joke about sky cranes when I was a kid, and here there is one. So in some ways, science fiction became science fact. But all of those problems led to solutions that enable us today to make products that stimulate markets and business places. Along the way, in the 1990s, there were some folks working on welding special materials using laser beams. And they were having trouble getting the UV, the ultraviolet dose, to the welding technicians down to safe levels. So they couldn't use it as a process until they figured out how to create a shield so that the welder would not be affected. Well, they created, and not only did the screen shield the welders from the harmful ultraviolet rays that came from the welding process, but it allowed them to see better than any welder's mask they'd ever seen. And what they had done was they had modeled this screen on the same basis as birds of prey, which apparently in their eyes have little droplets of oil. And that oil filters out certain wavelengths of light and allows eagles and hawks to see their prey from very far distances very clearly. So we patented the idea. A company picked it up and said, I can use this. I'm going to make sunglasses. And so today, you can buy sunglasses that are based truly on NASA technology. There's who was studying he got a space grant with us to look at the effects of sleeplessness on astronauts and how might we get the astronauts to sleep better. It involved using a lot of rodents, apparently. Not that astronauts are rats, but in the process, he discovered or actually he was playing with this effect called Sopite syndrome. Sopite syndrome is the effect that if you have a crying baby, you put them in a car seat and you drive around town for a little bit and they fall asleep. Well, it's hard to believe they call that a syndrome. It sounds like it's something helpful. But in fact, there's this low frequency rumbling stimulates your vestibular system in a way that causes you to be drowsy. Just figure out how to make astronauts sleep better. And in the process, he got a patent. And that patent then he took and formed a business and created an app called Sleep Genius. Sleep Genius actually has 3 layers. It has this low functioning rumble that helps the vestibular system fall asleep. And then he's got some pulsed vibration therapy that enables the brain to understand where in the REM cycle it should be. And then he lays on top of all of that some relaxing music. And so far today, 400,000 customers have downloaded the app. I don't know if they're all sleeping or not. So there's, I don't know how many of you came to see Katie Coleman the other night. Some of you did. Remember, she said that she had to exercise. Right. She didn't actually say how much. Every astronaut on board the International Space Station must exercise for 2 hours a day. And the reason for that is that we want to minimize the disuse atrophy of both bones and muscles. And what happens is you send an astronaut into space, they have a 10 times, they lose bone mass density at 10 times faster than the normal rate on Earth. So I messed up that statistic, but basically they get osteoporosis 10 times faster. Right? And so there are some ways that we were working on to try and prevent that in space because we know we're going to want to live longer in space and endure spaceflight, but ultimately we have to bring these people back and their bones have to function. So there was a guy at and he had a grant to look at this effect on bone loss and muscle mass loss in space. And one of the things he started playing with was vibration therapy. How might I use vibration therapy to overcome disuse atrophy? And in the process, he was able to determine that not only does the vibration simulate compression, the compression of bones on the Earth, but it also simulates the use of the muscles. So he applied for a patent, and in addition to helping out the astronauts, he's now got a business that is producing VibeTech 1. VibeTech 1 is a lower body machine for people who are of disuse atrophy. What that really means is they can't use their lower body for a variety of reasons. Sometimes it's temporary, like post-surgical reasons, and sometimes it's permanent. But you can exercise by putting your body into this machine for just 10 minutes. And so it's under test right now in hospitals and nursing homes in the United States. This is one of my favorites. How many of you flew on an airplane with a bent wing like that? Right? That's not bent like that because the pilot took the corner too fast. That's bent because it changes the aerodynamics of the wingtip, and the vortices that come off the wingtip then are actually used to help the plane lift instead of pull the plane down. And that technology was invented at NASA. Today, in the United States alone, 1 billion gallons of fuel a year are saved because of that. Now it's used all over the world. One that's a little older is in the 1950s. The agency backup was doing aeronautics research, and they did research on what they called a supercritical wing. Today, that wing is used in almost every commercial airline flight, airplane. And what it is it's the blending that you see between the fuselage and the wing. Previously, it had been a solid joint, and here they've blended it out and made it a lot more smooth, and they found the right ratio on the fuselage size to the wing chord width in order to make that the most aerodynamic. And it makes airplanes fly more smoothly, and it makes them fly more efficiently, which means you can either go faster or you can be more efficient with the fuel that you're using. A little more recent, NASA wants to fly astronauts to the space station on its own. Remember, we had to shut down the space shuttle program in order to be able to build the rocket and the systems that will take us deeper into space. And in the meantime then, what that means is that Russia is flying our astronauts to the International Space Station for us. Well, that's great. Russia's a great partner, but we'd really rather do it ourselves. And so one of the approaches that we went about was we said to the commercial industry, why don't you all get together and find a way to create a space taxi service or a space DHL, if you will. And so the industry's done that. We have commercial cargo and we have commercial crew. One of the contenders for commercial crew and commercial cargo is Elon Musk's SpaceX, which is, Elon, I understand, is from South Africa. Make sure the astronauts we sent into space would stay alive. And so we offered those companies involved in commercial crew the opportunity to take some of our systems and technologies that do environmental control and life support. We put it into a specialized box and we said, if you want this, take it. Because we would then be more confident that our astronauts would stay alive in orbit. Well, that's great too. Worldview, however, said, hey, we'll license that technology also, although we're not going to fly astronauts into space. What we're going to do is to fly a capsule to 100,000 feet. And the idea is space tourism. You know, the second space tourism was also a South African, Mark Shuttleworth. So space tourism, I believe, is on the rise as these technologies make it more and more affordable. So now next year you'll be able to buy a ride in this capsule. It will, in a shirt-sleeve environment, take you to 100,000 feet, which isn't space, but it's high enough that you'll be able to get the same view that the astronauts get from space. You'll linger there for a couple of hours using NASA technology to make sure you stay alive, and then the balloon that carried you aloft will be cut, and you will fly home on a parachute, a wing-shaped parachute. Hundreds of NASA bits of technology in that have been commercialized that enable this industry, the space tourism industry, to begin. I believe that someday you'll be able to take a ride to the edges of space almost as affordably as you might take a plane ride to Washington, D.C. Frankly, it would be more fun. We drill for oil a lot in the Gulf of Mexico and along the California coast, and sometimes there are oil spills, sometimes there are leaks. And some of the NASA technology for sensing the fatigue in the pipes, for understanding where the leaks might occur, and to closing those gaps comes directly from the experience that we've had on moving fuel in and out of the space shuttle. The details of those patents is a little complicated for a talk like this, but the bottom line is we've been able to take space technology utilized to keep astronauts safe, to keep people safe on Earth near our oil rigs. One of the very first missions I worked on at General Electric Company was a mission called Landsat. Landsat has a 30-year history of gathering data at 30-meter resolution. A Along the way, there have been many Landsats, 8, I believe. Along the way, we've tried to figure out what to do with all that data. At first we said, well, we're just going to use, NASA scientists will use it. Well, no, NASA, it shouldn't just be limited to NASA scientists. So we opened it up to more scientists, and they got a little bit of use out of it. But we thought, there's more here. So we said, well, let's commercialize it. And we'll charge a fee, because in the late 80s, early to mid 80s, I should say, it was difficult to reproduce the data at a resolution that could be useful, say, for town planners or farmers or farm bureaus, that sort of thing. So we would charge a fee. Well, nobody was buying because we were charging a fee. So then we tried another approach, and we said, well, we'll centralize it, and we'll advertise it, and we'll lower the fee. That really didn't work very well either. The data, I believe it was in 2003, but don't quote me, I have that wrong, that we identified the fact that we were going to give the data away. Google said, we'll take it. And within about a year, they had developed Google Earth, the Google Earth engine, that enables you to look at almost any spot on the Earth and look at how it's changed over 30 years. And now suddenly, this data set has become far more valuable than it ever was when we were trying to just recoup our costs. So there have been industries that, as a result of Google's innovations in these areas, that have spun off everything from overlays on Google Maps to planning tools for agriculture use, a whole variety of different things. We've got countries that are using this data to help them understand what areas within their country they're in with regard to forestry and land resources. This is one of my favorites too. This is a whale shark. Apparently they're very docile animals. I've not ever gotten that close, although I did go out on a boat one time off the coast of Maine, and there was a 15-meter whale shark that swam under our boat. It was an amazing event. But also, I'm told that the dots on a whale shark are very much like a fingerprint. So one of the things that happened was one of our Hubble spacecraft scientists, Hubble Space Telescope scientists, was having dinner with a marine biologist, and he was explaining how we know where the Hubble is at any given point, is pointing at any given point in time. We triangulate on 3 stars, and then we triangulate over here, and then we triangulate on that. And ultimately, we know exactly where in the night sky Hubble Space Telescope is pointing. Well, they got together and they said, I wonder if we could use that same algorithm on the dots of a whale shark. It turns out it works. And now, instead of having to tag the animal to understand it, all you need is a picture of it. And you can identify this whale shark from that whale shark. Furthermore, they said, well, let's push this a little bit further. There are some biologists that believe that the points on the whiskers, where points on the nose of a polar bear, where the whiskers come out, they're black. They believe those are all, that pattern is also unique. And so if you can take a picture of the black dots on the nose of a polar bear, I'm not volunteering to get close enough to do that, then you might be able to classify a polar bear without having to dart it and tag it. Robotics. NASA is known for robotics. We flew Robonaut 1 into the International Space Station. It's not quite outside yet. Katie mentioned it in her talk. If there's time, remind me, and I'll tell a tale on Katie, something she didn't tell you in her talk. The idea is to find a way to get humans and robots to work together. And slowly but surely we're doing that. Along the way, as we create robots that are more and more capable of doing tasks designed for humans rather than tasks designed for robots, we found that there's more and more things that we can do with that technology. One is we created something called a Robo Glove in partnership with the General Motors Corporation operations, repetitive motion disorders. So somebody working on an automobile assembly line, maybe they're picking up, say, a windshield 100 times a day, they could go home and their hands would be exhausted, and maybe over time they would have some disorder associated with that. The idea of RoboGlove is you put it on, you grab something with your hands, and it stays grabbed. It's an assistive device. And then you can pick it up and move the object, and then press a button, and it'll let go. Helping hundreds of people in the United States. The same with this, what we call it an exoskeleton down here. I've seen several of these being worked on, several government agencies, but this is our spin on the technology. You can strap it on, and we've been able to work with people with spinal cord injuries to enable them. It's pretty cool. The other interesting thing about this exoskeleton is, you've all seen the treadmills that we take into space. We could put one of these in space, astronaut could strap it on, and instead of assisting them to walk, we can resist them to walk, right? And so they get exercise that way. Fukushima. One of the really interesting things about Fukushima was the nations of the world sent robots to Japan. But they were pretty much unusable because the robots that we sent to Japan require that the field of play or the environment that they're in be robot friendly. Well, this is a disaster. Nobody could guarantee the field would be robot friendly. And so the nations of the world, the robotic nations of the world, have gotten together and through the U.S. agency, there's a competition, a world competition called the DARPA Robot Competition. That's pretty ingenious. The idea is design a robot that can get into a vehicle designed for a human being, drive a few kilometers, get out, walk across a debris-strewn field, open a door, climb a flight of stairs, and turn off a valve. If we had been able to do that, if Japan had been able to do that, we would not have had the Fukushima meltdown. And so this is NASA's answer to that. The technology designed into Robonaut has now been spun into what we call R5, and R5 is, we believe, capable of doing all those tasks. We'll find out when we get to the competition later this year. But along the way, we've learned a lot about robotics, and we've learned a lot of things, spin-off applications like the exoskeleton and robot. So I should back up here. See the astronaut spacesuit and the fabric? That's a very special fabric. That fabric is designed specifically to protect an astronaut from the environment of space. The heat of the sun, the cold when there is no sun, minor micrometeoroid damage, accidental snags and cuts on metal burrs and that sort of thing. It's his first defensive layer from being damaged or actually being killed by being out in space. A company made that fabric for us and then licensed it out to commercialize. And today, many football stadiums, including 2 in South Africa, have that fabric as the roofs of their stadiums. So I believe this one, if you look at the one as you fly out of Port Elizabeth, it's the same stuff. It's just scalloped. So you can learn more, this is my plug here, you can learn more about spinoff by going to spinoff.nasa.gov. And I think that's spinoff. So now let me just talk really briefly about how investing in space changes the way we think about ideas, the way we come up with ideas. And I'll be really brief about this. There's a group of guys, I think of them as teenagers, they're actually in their 20s, formed a company in California, and they built CubeSats. You can see an example of a CubeSat in, what's the name of the auditorium? Thomas Pringle Hall, a partnership between South Africa and France. these guys built 12, they called them doves, and flew them to the International Space Station and deployed them there. I'm going to try and show you a video of the deployments. Let's look, hope it all works here. There we go. There's two coming out. It's interesting, that one got a little bit of a tip-off rate, and so it almost ran into its brother. But these are little tiny, they call them CubeSats, but they're really about the size of a loaf of bread. Sorry there's no dramatic sound. There really should be like something, some massive sound playing. So you can see there's two more that come out. There actually was an incident where early on, not the doves, but early, one got too close to the other, and the magnetic attraction from the magnetic stability devices grabbed one of the antennas of the forward spacecraft, and the two of them got stuck together. But the neat thing about a CubeSat is they're very inexpensive to build, and you can fly on the margins of other missions. So the South African CubeSat that was flown recently flew as a secondary payload on a Russian launcher. See, is this? Oh, it's recycling. We're done. Okay, so that's what Planet Lab does. Well, what can you do with that technology? Why would you bother with that? You know, these are little tiny satellites made by some teenagers, actually 25-year-olds. And, well, the reality is the technology in imaging has gotten so good that you can take a picture of New York City. You can actually go online and order a dove picture taken of whatever latitude and longitude you ask for. Right? Here you can see boats moving up and down the Hudson River. You can see one, it's a ferry actually moving to the east towards Manhattan from New Jersey. I should also point that island in the lower center is Ellis Island. You can also, this looks like art, doesn't it? You can monitor the environment. This is a Planet Labs dove image of effluent in a bay in Madagascar. So you can get an idea of how valuable something like this might be, not only from an artistic standpoint, but from an environmental monitoring standpoint. So that was Planet Labs and launch, one of the things that we've done at NASA in partnership with another government agency called USAID and the sneaker company Nike, we have set up this program called Launch, and it is a worldwide search for innovators, people that want to start their own business to solve a particular problem. And these are people that are looking for ways of making clean water. These are people that are looking at ways of bringing eye protection and eye diagnosis glasses to people who may not have access, and a variety of other things. One of the things that we do is we bring these people together, we give them training, we give them introductions to like venture capitalists and challenge them to think more broadly about their solutions. And we, as NASA, we get to play with new forums for coming up with new ideas. Launch has been very beneficial in NASA forward into the social media age. Another idea is, when you have sort of a vague problem, you can give it to a crowd and ask a crowd to look at it. So the International Space Apps Challenge happens every April, and what's really cool about this is a group of people take a problem, they start designing an app. They work until they're tired, like 8 hours, and then they hand it off. If they're in Port Elizabeth, they might hand it off to somebody in New York City. And that team in New York City will work on it for a little while, and they might hand it off to somebody in California. And then they'll work on it for a little while, and they'll hand it off to someone in Tokyo. Well, when the people in Port Elizabeth wake up, the thing they started is totally different, but it's actually more functional, and it's been crowdsourced. Well, that event is going to happen in April, and I'm proud to say that there are 3 teams from South Africa, one in Port Elizabeth, one in Pretoria, and one in Cape Town. So that is how investing in space exploration can be brought to bear to change life on Earth. And if we have time, I'll take some questions. Thank you. And if you're a kid and you're still awake and you ask a question, I've got a stick. It's really hot in here, isn't it? Yeah. Who's got a question? Yes.
The robot is based very much on human form. Is it just because it's cuter and it's easier for us to get on with, or is there a reason for that?
So it has a feminine form. Are you talking about the
It just still has
R5?
two arms and two legs.
Oh,
and,
I see.
It's not
Yeah.
like a spider or something.
No, that was intentional. We wanted to make it mimic the first robot that we built, Robonaut, specifically to be the same form factor and have the same dexterity as an astronaut in an extravehicular activity suit. And the idea was, if we made that robot that size, we could get it through an airlock, and if it had the same dexterity, it would be able to do the same tasks as an astronaut. So yeah. Yes.
You said you had a story that.
Oh,
There's time.
that's awesome, and there's time. Okay, so Katie Coleman now works for me for a year, right? I have to tell you, having an astronaut work for you is really hard. But she's awesome. She's also quite a practical joker. And so, you know, NASA engineers, we're pretty serious guys. And we have a procedure for everything. We packed up Robonaut, we put it in a box, procedure for how to unpack it. Sent Robonaut to space, gave it to Katie Coleman, who was on the International Space Station at the time, and the day came to open up the box and unpack Robonaut. Well, you can guess what happened. We're going through the procedure. I wasn't there, obviously, but the engineers were going through the procedure, and they're saying, okay, now turn bolt R9 3 degrees to the right and lift. You know, and now go do that to bolt R10. You know, that's just really boring, to tell you the truth. And so when Katie followed the procedure and took the lid off the crate, there was no Robonaut inside. And the guys' hearts sank. One guy almost cried. Turns out she had started work early, opened up the box, pulled out the Robonaut, which is no mean feat because this is the size of a human being, right? Locks up perfectly, and then you know, proceeded to exercise. So there is a little humor on the International Space Station. I guess if you're stuck up there for 6 months with people, you gotta have a few things. Somebody else. By the way, for you guys in the red there, I can answer a question on almost anything. Anything from is Pluto a planet to how do astronauts go to the bathroom in space. So
Please answer that.
please answer that. They do it very well. So, all right. Anybody else? Yes.
What were actually the spin-offs from the Apollo mission?
Boy, I don't have them totally memorized. But from that era, do you remember the space blankets, like emergency blankets that you put in the trunk of your car? That's
Teflon.
I'm sorry?
Teflon.
Teflon. Teflon was not invented as a result of space, but it was used widely. And so it got a lot of testing and a lot of promotion because of its space activity. One of the things that we were working on in the 70s at the Jet Propulsion Lab was a new form of charge-coupled device to make very, very tiny cameras. And today, that device is in almost every iPhone in the world. It was licensed from NASA. So, yes?
When you want to send probes to really exciting places that are very far off, it takes you years and years to get there. And we're not even talking about other solar systems. Is NASA working on other propulsion systems that would go faster?
Yes. Please expound, huh? Okay, so there are some technologies that would enable us to do better propulsion. One of them is nuclear, so I'll just go in order of craziness. Right? You know that the way a propulsion system works is you take a bit of mass, you accelerate it, and you spit it out one end, and Newton's, what is that, second law, third law, thank you, says that you're going to go the other direction, right? Every action has an equal and opposite reaction, right? And so today what we do is we put fuel through a catalytic converter, cat bed heater, and that creates a flame, and that fuel then is accelerated out of a nozzle. Or we might combine it with something else that causes it to heat up, and that becomes fuel that comes out, or the jet that comes out of the nozzle. One of the things that we're working on is taking a fuel. We haven't decided what it will be yet. It might be hydrogen. It might be something heavier than that. And running it through the core of a fission reactor. Well, that superheats it. And that makes this mass go faster out the jet, out the nozzle. So that's one idea that actually we're pretty far along on. In fact, it was proven in the 1960s, and then we shut the program down, and so we're bringing it back and using today's technology. Another idea is something called bosmere, which takes a fuel and ionizes it and runs it through this electric grid and forces it out the back end. It's an ion propulsion system on steroids to do ion propulsion systems. That, if it were to work, it would cut the transit time to Mars for human beings in half. Right? So right now it takes 8.5 months to get to Mars. Bosmere would take like 4 months or 5 months. But the issue is you need a lot of power. You need a nuclear power system in order to be able to do that. So now you got engineers fighting because, well, if you're going to take a nuclear power system and make electricity to push fuel through an ion grid, you might as well just take the fuel and run it through the reactor and take some of that electric stuff out. Anyway, there's lots of debate over that. Then you get into some of the even more insane stuff. There's a guy at Johnson Space Center who points out that in quantum physics, apparently empty space is not really empty. That at any given point in time, electrons self-propagate and self-annihilate. And so his theory is if he could play with the probability function, if he could change the probability function by doing something in that space, then he might be able to capture, for a moment, those electrons. And he would reduce the transit time from here to Mars to something on the order of weeks. Right? The problem is, he also needs a huge reactor in order to be able to make that happen. So it turns out that anything that's going to help us go faster in space has some sort of nuclear component to it. So the answer to your question is, yeah, we're working on these sorts of things. Yes?
From the small debris in space going faster,
Yeah.
what materials are you going to use?
So one of the things, one of the most hazardous zones in space is low Earth orbit. Because there's all kinds of bits of trash up there. Leftovers from old rockets or satellites that have collided into each other. There's an old glove from the Gemini era. So there's all kinds. And I remember seeing a hole, didn't go all the way through, a gash in a space shuttle windscreen that was about this big around and about that deep. And it was made by a paint fleck. The interesting thing was that the analysts were able to analyze the paint and trace it back to a Russian spacecraft. But in deep space, there's still bits of stuff out there. To be honest, we don't really worry about it that much. I've flown missions to Mars. I've flown missions, like the Juno mission is on its way to Jupiter and has passed through the asteroid belt. And we've really never had that much trouble. It's closer to home. It's closer to Earth. there's a classic story about the company Surrey Satellite Technology Limited. They're in the UK. And they make these satellites, or they did make these satellites that were a little bigger than a CubeSat, but they had a long boom on them. And that allowed them to stay stable due to the gravity gradient between the top of the boom and the bottom of the satellite. And one day, they went and they made contact with a spacecraft, and it was tumbling. And they were scratching their heads, and they said, well, that's a physical impossibility. You can't make a gravity gradient satellite tumble. So they asked some radar folks in the UK to image it, and the radar folks said, we got a picture of it, and we've got all 3 of your pieces. And it turns out, and this is the thing that they think is so amusing, it was a satellite they had built for the French. It turns out that a piece of an Ariane, which is a debris, had sheared off the boom about a meter above the spacecraft. So the French did it themselves. But the bottom line is that the space debris deeper in space, we don't worry too much. Although I will tell you that when Pluto gets to Jupiter, or when New Horizons gets to Pluto this July, buried inside its thermal blankets is a layer of Kevlar for that exact reason. We've flown the New Horizons probe now for 9 years. It's going to fly by Pluto in July, and we sure would not want to run into a bit of micrometeoroid in the Plutonian environment. And so there is well, the New Horizons probe has a bulletproof vest. So, yes?
Just something about the air inside that you more or less the same as here, or composition, and how do you keep
Yeah, we try to make it the same composition, but depending upon what the chamber that you're in is for, they may change the pressure, right? And that has its roots actually in scuba diving and deep diving, because you're trying to change the way the body responds to the pressure and the oxygen content. It also has to do with the fact that if you're in an EVA suit, extravehicular activity suit, like you saw the astronaut in, that pumps up the gloves quite a bit if you got the pressure too high. So they actually get the astronaut in the suit, and he acclimates, and then they slowly lower the pressure to the point that he can actually use the gloves. So. Oh, we have questions in the top, way in the back. Yeah, Aldi.
Next question. How environmentally sustainable are launches into space?
Environmentally sustainable. So everything that we try to do, we try to meet environmental regulations. Everything. But much of the time, we do have to use we use kerosene in some of our rockets. That's why sometimes you see smoke. The space shuttle was very environmentally sustainable. It used hydrogen and oxygen as a fuel, right? What we do is we throw pieces away and they fall into the ocean. We believe that they're benign by the time they get to the surface of the ocean, and we create reefs as a result of that. We are trying to find ways to reuse those things. Elon Musk is pioneering a way to take his first stage booster and have it fly back to the launch pad. That's kind of cool. That's pretty innovative. The other thing that we are doing is we're trying to make sure that whatever we launch into space doesn't create more debris. And so there are internationally established regulations on how long an object that you leave in orbit inert can survive. I think it's 25 years, and then it must re-enter, and there's a limit on how much of it can actually reach the surface of the Earth as it burns up on the way in. So, Kelly had a question.
Okay, so with the robots, are you trying to replace all human astronauts with robot astronauts? And if so, do you think it's worth this whole one-way ticket to Mars?
Oh. So you're combining two concepts, all right? So the success of the Apollo mission was based on the learning that we got from robotic probes that landed first. So what you see we're doing on Mars, like with the rovers, is we're learning about Mars now, while we're getting astronauts and the systems ready to take astronauts to Mars. And I'll tell you right now, we don't really have everything we need to take astronauts to the surface of Mars. So we are spending time with robots learning how to move around Mars, what it's like, how to deal with dust, how to dig, a variety of other things using robots. What I will say is that NASA strives to make sure that everybody they send into space is as safe as we can possibly make it. And that does not create sustainable or return environment is not one that we would endorse. So that's about as much as I'm really supposed to say about Mars One. I think it's innovative, and I really hope that by the time they actually execute, that the mission itself is a return mission. So.
Last question.
Yeah, last question. Yes.
What's the most exciting thing that could happen feasibly in your lifetime?
Oh my goodness. I know that immediately.
I'm sorry, we don't have to.
Okay. I'll see you after. No. Finding life beyond Earth. In whatever form that comes. It could be microbes on Mars. It could be algae in the European Sea. It could be oceans, although that's unlikely. It could be, we get an intelligent signal from deep in space somewhere, and we start puzzling our head, scratching our heads. I think finding life on Earth, or finding life beyond Earth, intelligent life on Earth. It has been a long week, hasn't it? Is one of the things that the challenges for this century. Yeah. All right. Well, thank you, everybody.
Yeah.
Is that it? Are we done?
Almost.
Oh.
So I have an instruction for you. Actually.
Oh my goodness.
Before I let the audience go, it doesn't really have anything to do with spin-offs, but I would like you to tell them the story about the wheels in the rover.
Oh. If you go outside and you look at the cutout of the Mars rover Curiosity, there were several designed for a variety of reasons. And I went out to take a look at one called the Scarecrow many years, 5 years before we actually launched Curiosity. And it was running around the simulated Mars area they called the Mars Yard. It was kind of cool. But on the wheels, as a backup, we put visual indicators so that if for some reason we lose count of how many times the wheels have gone around, or we're just not sure what distance we've traveled, we can look back at the tracks that we made, count the number of visual indicators off into the distance, and we can say, okay, well, we've been this far. So the visual indicator on Scarecrow was a rearrangement of the tread design to spell JPL, which is Jet Propulsion Lab. They're a portion of NASA. There's a bit of NASA, Johnson Space Center as well. Anyway, so I said to them, look, that says JPL. You're not going to leave the phrase JPL all over the surface of Mars. It ought to at least say NASA or USA or Earth or something, but not JPL. And they said, okay, you're right. So, long time passed. I get a visitor in my office who's not from JPL, and he's waving this picture, and he said, do you know what this says? And I said, what are you talking about? Those are holes in the wheels they chose to put there as visual indicators. Right. They're visual indicators. But look at the holes. And if you go out there and you look at the holes, they're not all the same. The holes are Morse code for JP. So I to the United States because they're very heavy, but I have 2 copies of 2015 spin-off. If somebody wants them, you can. There's a guy here that didn't ask a question. There you go. And I'll give it to the young lady in the back. You come on down. All right. Thank you very much. Is that right?
We are. Thank you very, very much, Jim. Round of applause, please. And with 3 minutes to spare.
Awesome.
Well done. Jim did mention earlier, that he was saying one of the most exciting things for him would be, if we found life, out there. In fact, you have a bet going with Jim Green.
I do.
For a steak dinner.
Yes.
You at the short end of that steak dinner.
Yeah.
I'm going to say yours. But that brings me to my next point is that please join us tomorrow at 1 o'clock. We will be doing a Google Hangout with Jim Green, who is the director of the Planetary Science Division. And he'll be looking at the New Horizons and
Dawn.
series.
So New Horizons is the mission that flew over Dawn. It's a series.
Very confusing. But it is a very exciting year for the Planetary Science Division at NASA. In fact, he used to be your boss.
He did, and that's when we made the bet about life on Mars.
Yeah, and he's going to be on a plane tomorrow, so we can dig out dirt and Jim. So please join us at 1. I think that's going to be a really exciting session. But again, Jim, thank you very much. There's 2 minutes if you want to ask questions while he's running.